Hi class, alright, so no video of me this time only because there's a lot of information on these slides. I don't want my face covering anything up, but you get to still hear my beautiful voice. Let's get right into it because engineering disciplines is a kind of long one, but it's a really important one. We've already talked about what engineering and engineers do in the last video, but just to summarize it, we're using our math and science technical skills in order to problem solve, but we're problem solving with a purpose in order to improve people's lives. So what are the big disciplines you can get into, and what type of engineering or engineer can you become? The big four fields of engineering, and this will definitely come up at some point, whether it's a quiz or me just bringing it up, are chemical, civil, electrical, mechanical. Say that again: chemical, civil, electrical, mechanical, chemical, civil, electrical, mechanical. That does not mean these are the only four. It just means that these are the major engineering fields, especially like what's important about this is if you're going to go to college, these are the big four engineering fields that typically offer majors in. It doesn't mean that these are the only ones. There are other engineering fields, but a lot of times they're off branches like derivatives or combinations or extensions of these four. But it's important to know that these are the biggest four, especially if you're thinking of going to college and becoming an engineer. You're going to want to know that these four are kind of the main majors that you can pursue, and then you can specialize in a specific type of engineering field that's a subset of one of these four. So let's look at each of these four. Chemical shouldn't be a surprise, but you're applying chemistry, physics, and engineering to design and operation of plants for the production of materials that undergo chemical changes during their processing. Okay, so this is really cool actually. So chemical engineers, what they do is they use chemistry and their knowledge of chemistry in order to potentially create or redefine or kind of innovate the use of different materials. So they might actually be creating new plastic or synthetic textiles or medicine, anything like that. We're going to get into, and we're going to see like bioengineering and see how this is an offshoot of this, or maybe material engineering. But chemical engineering as a whole, they're using their application of science in order to create new products, okay, or improve on existing products that already exist. Really, really cool. Very good major to go into. A lot of times, just as some background, a lot of times they actually go into new fuels. Maybe not necessarily new fuels, but the most popular chemical engineering company to work for is one of the petroleum companies. So whether it's BP or like a Chevron or any of those types of companies, a lot of times they look at chemical engineers in order to oversee their refineries, and so often you're going to be working for that, but doesn't mean you can't go into many of these other fields. Civil and construction engineering, this is what I was in. So you plan, design, supervise the construction of facilities. Fairly straightforward. I do want to clarify a little bit that a lot of people think of civil engineers as maybe bridge builders or roads and stuff like that. I mean, it could be basically anything. It could be dams, it could be buildings, it could be any kind of structure. Civil and construction engineering, I mean, we care about anything that involves civilians. So if it's a building, a civil engineer is involved. If it's something you walk on, civil engineers are involved on. If it's something that involves like a water treatment plant, a civil engineer will be involved in that. Why? Because it affects civilian lives. Okay. So we might also be designing airports, irrigation projects, tunnels, all those types of things. Collection and treatment of wastewater. So it's, again, anything that involves civilian life. Electrical and electronics engineering. This is a really good one. This is obviously you're working with electricity in order to power different systems. So it could be something like home design where you're powering a house or a building. It could be something like a car where you're powering or designing the battery. And you're working with maybe a chemical engineer in order to design a new form of battery, but you're the electrical expert and know the needs of a vehicle in order to move. Lastly, mechanical engineer. They're the ones that are taking mechanics and energy in order to create new machines and devices that give us power in order to move. So whether that's something like what we see here, like a motor, that's brought up from a mechanical engineer. It also is something like HVAC. If you don't know what that means, heating, venting, and air conditioning. That means that the cool air that we feel inside a building, and the AC unit that was built was designed by a mechanical engineer. So these are the big four. So again, you got to remember them: chemical, civil, electrical, mechanical. Say it again: chemical, civil, electrical, mechanical. But it does not mean, oh, and there's some more things mechanical engineers do, it does not mean that these are the only four, because there are so many more disciplines. It's ridiculous. There's so many. Aeronautical engineers, if you're really into planes, this is more of an offshoot of mechanical engineering. So it's kind of a, when people hear aeronautical versus aerospace, aeronautical is going to focus on planes, aerospace is going to focus on space, so getting out beyond our stratosphere, okay? Aeronautical engineers will design, the new jet planes that the military uses, or maybe the new Boeing planes that are going to be up in the sky, or maybe even drones and stuff like that. They're going to focus specifically on flight, but on Earth. So they're going to be really worried about aerodynamics, propulsion, controls, and structure. That is different than an aerospace or astronautical engineer. That you're more focused on environments not found on Earth, which means space or even beyond that. Okay, so like Mars exploration. In order to get there, aerospace engineers are going to have to design a way for us to be able to do so. Okay. Agriculture engineering, not as popular here, but actually a pretty big engineering field in the Midwest or other parts of the country. Agriculture engineering focuses on how we can design nature in order to improve growth of plants or food on Earth. They might be also worried about electrical power generation, so things like we're going to learn about how you can get energy out of the ground. They might be focused on that, but their biggest kind of areas of concern are going to be soil and water and food. They're going to be focused on how can we better grow plants and food life. Okay, again, maybe not as popular here, but even in Central California, probably a big need. You should be aware of the fact that you're probably not going to be working in a big city if you're an agriculture engineer, but there are jobs in a lot of areas for these folks. Architectural engineering, it's kind of a combination of architects who design buildings and a structural engineer who focuses more on the skeleton of the building, making sure it can stand. Architectural engineering is a subset of civil engineering. You might go into civil engineering and get a minor in architecture, so you might become an architectural engineer and go into that field. Definitely something to consider. Automotive engineering. This year specifically focused on any kind of automobile, which makes sense. It doesn't mean just the car you drive, but maybe tractors, bulldozers, all those types of things. Automotive engineers are offshoot of mechanical engineering, but you're focused specifically on automotives. Biomedical engineering, this is a cool one. This is an offshoot of chemical engineering. This is where you're taking your understanding of chemistry and physics and all these types of things, but you have a more deeper understanding of the human body. And so you're actually designing and bioengineering ways in order to make humans live forever, or not get sick, or not have to have a bad knee when I run, those types of things. You're trying to create a better life for people in their health. And this is actually a really cool one. I think there's a big need for this. If you hear about like nanobots going in and curing cancer and stuff like that, this is work of biomedical engineers, along with other engineers as well. But you're more specifically focused on the human body and how we can live forever, we'll say. Computer engineering. This is a big one these days. So if you start thinking of robotics and automation and all those types of things. Computer engineering deals with hardware and software, so you might be developing apps or programs or even faster computers. You're more specifically focused on, you would have to have some kind of CS, computer science background, and be quite familiar with the manner in which computers work. Definitely an offshoot of electrical engineering. A lot of times you work for automotive industry, and that's because they're trying to design better processes and use computers in order to build factory lines that will build cars for you as opposed to human labor. So again, a lot of that automation type stuff. Industrial engineering, this is an interesting one. A lot of people don't know about this. You're actually the expert in trying to understand how to better manipulate work in order to improve production. So you might be hired by a factory in order to design the way in which materials are manufactured. So, excuse me. So I'll show you a video at some point in terms of Boeing industrial engineers and how they created a factory line that was most efficient in order to be able to basically push out these planes as quickly as possible. And so they're kind of the experts in systems analysis and confirming the most efficient way in order to do things. So you might also be maintenance of machinery. So you might be on site, and an industrial engineer could also just be responsible for making sure equipment works. So that's something really important as well. Manufacturing engineering, design of manufacturing facility for a product or products. So you're going to deal with the physical plant layout. So where is equipment going to be going? How does new equipment or existing equipment that we have work, and creating maybe manuals in order to ensure people know the instructions in terms of how to use it. You might be responsible for actually purchasing this equipment, so you might be on the purchasing side where you don't actually do anything except just buy equipment for a company, or like maybe you're responsible for how this machine is going to get packaged, and you're writing the guidelines for how to package or unpackage this material and install it. So in conclusion, these are just some of the different disciplines. You'll realize that there's so many more. The big thing for this one is realize that there's the big four, and then there's offshoots of those. And I could probably tell you 20 more engineering fields and disciplines that exist. You'll learn about more of them even in POE. The big concept is to understand that there are a lot of engineering disciplines and have an idea in terms of what each one does. So if I were to say something like, what type of engineer would deal with planes specifically, you would know, okay, is that an aerospace or an aeronautical? And you might be able to match up a couple of the types of engineering disciplines with what they're going to be responsible for. The big four are going to be the most important thing to take away from here, and that's more specifically what I'm going to be focusing my questions on. But you do want to have a basic understanding of the other engineering disciplines. All right, thank you so much for watching.